Well, good morning, ladies and gentlemen. Today we are starting our last full unit of the units trigonometry and the unit circle. We're going to skip over the warm-up part. This would be a part we would discuss in class. But again, if you want to look at these questions and kind of think about it, you can. But since this is a video, can't really compare things like that. But we're going to go into example number one. All right, so example number one, we have navigation application. The sextant is an optical instrument invented around 1730. It is used to measure the angular elevation of stars so that a navigator can determine a ship's current latitude. Suppose a navigator determines a ship in the Pacific Ocean to be located at north latitude 15.735 degrees. How can this be written as degrees, minutes, and seconds? All right. So in order to start this, what we're going to have to do is we're going to leave, now you don't have to circle this, but I'm just circling for point. We're not going to bother this 15 right here, okay? So we're going to skip over that because we're going to need that in our final answer. What we're going to focus on is the decimal. All right, this decimal right here. All right, well, I'm sorry. Got a little trigger happy with that. Right here. All right, so what we're going to do is we're going to take the decimal of 0.735 and we're going to multiply it by 60. Because remember, we're converting this to minutes and seconds. So there are 60 minutes in an hour. So basically a degree is considered an hour. All right, so the first thing we're going to do, so we're going to wind up with, when we multiply 0.735 by 60, we're going to wind up with 44.1. All right, so 44.1. Now, since we have a 0.1, we have to get, that means we have some seconds to consider. So now what we're going to do is we're going to take this 0.1 and multiply it by 60. All right, so remember that 0.1, because remember there are 60 seconds in a minute. So remember, we have 44 minutes. That's what that 44.1 represented. So the 0.1 is the seconds. So 1.1 times 60 is equal to 6. All right? So now, remember, we had to change it to degrees, minutes, and seconds. So our degrees we already had. So it's going to be 15 degrees. And then we're going to say 44 minutes. And we use the one little apostrophe. And then for the 6 seconds, we're going to use 2 apostrophes. Okay? So that's how we change a degree with decimals to minutes and seconds. All right? So let's say we're given the degree, the minutes and seconds, and we want to change it to a decimal. All right? So we already got the 39 here, so we don't have to worry about that. So now we're going to focus on, and I'm going to erase that again, sorry. We're going to focus on this part right here, the minutes and seconds. All right? So for the minutes, what we're going to do is we're going to divide it by 60, because remember, there are 60 minutes in an hour. All right? So 5 divided by 60 is going to give us, sorry, I'm trying to get it exactly, 0.083. And we'll put a little bar here because it does repeat. All right? So that takes care of our minutes. Now, if you have seconds, you have to go to the second step. Now, sometimes we may have a problem that doesn't have seconds, and in that case, we stop there. But since we do have seconds, we're going to, instead of dividing by 60, like we did when we converted it from decimal to seconds, we actually have to divide by 3,600. Because there are 3,600 seconds in an hour. And so that's why we had to do it that way as opposed to dividing by 60. Because remember, we want this to be a whole decimal. We're not going to separate it by apostrophes or other notation. So when we do that, we wind up with 0.0094. All right? So now what we're going to do is we're going to add. So we're going to say, I'm going to draw a little arrow here. We're going to say 39 plus 0.083 plus 0.0094 is going to give us 39.093, because remember it's to the nearest thousandth. So thousandths is 3 decimal places. So again, that would be what we would say as our answer. It's 39.093. All right, so that's the first thing we're going to talk about. The second thing we're going to talk about is given the angle measure represented by each rotation. So remember, in a circle, there are 360 degrees. Now, there's a couple things you want to pay attention to. For letter A, it says we're going to do 5.5 rotations clockwise. Anytime we have clockwise, remember, it's, again, counterintuitive. You would think as you go around the circle, around the clock, you actually, if you're going clockwise, you would think you would go positive 360. However, again, this is where it's a little backwards. We're actually going to go negative 360, okay? So we're going to say 5.5 times negative 360. So when we do that, we're going to wind up with negative 1,980. When we get to the unit circle later on in the unit, you'll understand why we're going negative and positive. But for right now, just know that if we're going this way, we're going like this way in a circle, as I'm drawing here on the A, in front of my A, that means we're going to go negative 360. So counterclockwise is the other way. It looks like this. All right. So if clockwise was negative, that means that counterclockwise has to be positive. So we're going to do 3.3 times 360, positive 360. I'm going to wind up with 1,188 degrees. I'm sorry, I forgot to put degrees here. All right. So again, that's another thing we're going to talk about is, so remember that counterclockwise is always going to be positive. Clockwise is always going to be negative. All right. Example number 3. It says identify all the angles that are coterminal with each angle. Then find one positive angle and one negative angle that are coterminal with the angle. So here, it's kind of the same concept here. What we're going to simply be doing here is we're going to either be adding and subtracting 360. So we're going to start with 45. So we're going to say 45 minus 360 is going to be 315, negative 315. All right, make sure it's a negative 315 degrees. All right, and then we're going to do the same thing with positive 360. Because you have to do both sides, because we'll talk about this a little more when we get to the unit circle. You have to do a negative and a positive side. All right, so that's going to be 405. So you're going to have a negative answer and a positive answer for most of our problems. Sometimes they'll both be positive or both be negative if the number's low enough. But, I mean, one's be positive, one's be negative. But, again, how big it gets is just depending on what degrees we have. And we won't go over 360, so we'll basically, for this part, we won't go over 360 on this part. All right, so now we do the same thing for B. 225, we're going to add 360 and get 585. Now, when I say we won't go over it, I mean the first initial angle won't be over 360 for most of these parts. All right, and then we're going to say 225 minus 360 is going to be negative 135 degrees. Now, you always want to put degrees here because, again, we're talking about a circle. So guess what? Anytime we have a circle, we're going to talk about degrees. All right, example 4. If each angle is in standard position, determine a coterminal angle that's between 0 and 360. State the quadrant in which the terminal side lies. All right, so all that basically means here, ladies and gentlemen, is we're going to do this, essentially, we're going to do the same thing, and hold on one second, I'm sorry. Okay, sorry, I had a brain fart here. So what we're going to do is we're going to take the 775 for letter A, and since essentially we have to go around the circle 2 times, because remember 360 is degrees in a circle. Since 775 is the nearest multiple of 360 is 720, we're going to say, essentially, we're going to say minus 360 times 2, which gives us 775 minus 720, and that's going to give us 55 degrees. All right? So that's how we handle when it's a positive number. What happens if it's a negative number? All right, it's going to be the same concept. We're going to take negative 1297, and again, remember how many times it goes around the circle, which in this case, we're going to be adding 360 4 times. 4 times 360, because again, it goes around the circle 4 times, and that's going to give us negative, when we go in here, it will give us, 1 second, let me do my math real quick. Sorry, I had it written out, and then for some reason I did not have it written out. 1 second. Sorry, ladies and gentlemen, I usually have my calculator handy, so I, for some reason, did not. 360 times 4, and that's going to be 1440. And when we add the two together, we're going to wind up with positive 143 degrees. All right? So if you have any questions, just pause. You can go back and rewind it and go from there. All right? So for example 5, it says find the measure of the reference angle for each angle. All right, so we have 120. So basically what we're going to be doing here is we need to make some notes here before we continue. All right, so for our first option is if the angle is between 0 and 90 degrees, our reference angle is going to be the angle. All right. Our second option is if it's between 90 degrees and 180 degrees, our reference angle is going to be 180 minus the angle. All right. I'm kind of extending over here, guys, so I have enough room. If it's between 180 and 270, the reference angle is going to be angle minus 180. And again, we'll keep these notes just in case we need them. So I definitely want you to write this stuff down. And then lastly, number 4, we have 270. If it's between 270 and 360, the reference angle is going to be 360 minus the angle. All right? So now let's apply one of those rules to this. So for letter A, we're looking at 120. All right, you look at the angle, which one it falls under. It falls under rule number 2 because it falls between 90 and 180. So that means we're going to say 180 minus 120 equals 60 degrees. All right. Now for B, what you have to remember is it is negative, but what it is that essentially the reason we tackled a positive number on the other one. When it's a negative number, you have to remember, you first of all have to add 360 to it. So we're going to say 135 plus 360 because our rules didn't say anything about negative. So that's going to be 225. So now that we know it's 225, that fits between rule number 3, which is 180 to 270. We're now going to say 225 minus 180 equals 45. So when it's negative, you have to add 360 before you use one of your rules. And if it's positive, it should fit rule 1, 2, 3, or 4. All right. Well, that will finish our discussion or our first lesson on angles and degree measure. Hopefully you enjoyed it. So going back to a little geometry, so I will go and tell you this unit is heavy in geometry. So hopefully you liked your geometry teacher and learned a good bit from him. But again, we'll revisit some concepts. So thank you, and I'll talk to you later and see you in the next video, or talk to you in the next video.